and I'll start it.
Well, Kristen, thank you very much. Can you hear me?
Yes, I can. Thanks for checking.
It's always good. So thanks, everyone. So welcome to this first of a series of events that we're branding as the Summer Lunch and Learn series for CA Privileged Access Management. Again, I am Steve McCullough. I'm the market-focused advisor for this product. At each week, we're going to be bringing in a subject matter expert to cover a particular aspect of privileged access management. As you'll see, it's a broad topic, and rather than dumping a lot of information or everything we can on a multi-hour webcast, we decided to break it into 6 parts. And today's session is a focus on a really high-level overview of why privileged access management and why in particular CA privileged access management. Our subject matter expert today is Chris Tippett, who's a senior principal consultant with CA, and Chris will be driving the demo. When I pass it over to him, I'll let him introduce himself. So the series, again, is being broken into 6 parts. Today's is focused on breaking the breach kill chain. This really talks to why you need to do something about privileged access management at all, why our customers are choosing CA. And we're going to give you a broad overview of the capabilities that we deliver. As you see, it's more than just a credential vault. That particular topic, in fact, is the focus of week 3. So today we'll be describing privileged access management as a defense against breach, and I'll be passing it to Chris for a demo of that. In subsequent sessions, we'll be covering in more depth particular aspects of features and capabilities that you're going to be seeing today. So today is going to be a really wide, but possibly not that deep look at privileged access management and CA privileged access manager in particular, and we'll be doing a drill down into different capabilities in subsequent sessions. So to begin with, why do something about privileged access management? Well, this particular slide in the deck is one that could be updated on an almost weekly basis. The breaches that are happening now are quite ubiquitous, kind of dizzying that they happen, and they've been very damaging, as you know. There's a number that we've included up here, such as Home Depot, the Anthem breach, the OPM breach from last year, the Ashley Madison breach. Hopefully nobody on this call was affected by that one. And but these are all examples of breaches that took place by malicious actors with different motivations. But the result was pretty much the same. Financial loss or loss of reputation, very damaging. One thing that they all had in common is that they involved a breach of privileged accounts. The topic of today is the kill chain. The kill chain is itself a military term. It was derived by an attacker who is trying to take out an opponent, that is to kill somebody. And to do that, there are certain steps that they work through in order to achieve this kill. And in the computer industry, this has been adapted for a breach, and in this case, the attackers are attacking you. So if you are the target, you are the one who is attempting to be killed. So the kill chain is the steps that they take in order to breach your defenses, such as they did with companies that are displayed on this screen as examples. The privileged accounts and privileged access do have a very important feature. They're required. You really can't run without them. The legitimate use is that system administrators, network admins, other administrators, every application, database, what have you, has the concept of privileged accounts. The privileged accounts themselves are actually a security measure, if you think about it, because not everybody who uses an application should have the same authority to configure the application. You wouldn't trust everybody with the authority to configure a database, to configure a server if they're just users of it. So you hide these configuration and administration capabilities and entrust a small number of users with the authority to perform those actions. And those are privileged users. They may have their own account or other accounts, possibly a shared account that they use to perform that administration. So you can't live without it. Somebody has got to keep the systems up, running, optimized, and it's administrators who do that. These privileged accounts that they use for that purpose do bypass normal security controls. So they have special privileges that I mentioned other people don't necessarily have. So along with this authority and responsibility to administer these systems also comes the power to abuse that privilege if they wanted to. So you actually, these people can do things via this insider threat, to perhaps steal data or do other things that they were not intended to do. Edward Snowden, of course, the poster child of the insider threat, and how he used high privilege credentials to perform actions that his employer wasn't expecting him to do. These privileged accounts then are used not only by internal users, but also as you open your enterprise up, you may have cloud-based, SaaS-based applications such as Office 365, perhaps partners who connect to perform administration. And as you open the enterprise up, maybe to do AWS, you also have hackers who now penetrate your defenses, secretly land in an unnoticed way. Maybe they're planting malware, looking for a base to land and then later to expand. So the number of privileged accounts you have might exceed the number of people you have in the company. And so being able to control what these privileged accounts can do and still allowing administrators the authority they need to do their job, which is very important, that becomes the delicate task at hand. How do we perform privileged access management? Now, in the concept of the defense in depth strategy, privileged access management is a necessary one. It's not the only one, but it has become just as important as other control measures that you're used to hearing about. You wouldn't consider running your enterprise without a firewall. You wouldn't run it without antivirus, for example. And in the same way, since breaches are taking advantage of privileged accounts and abusing those accounts to perform their malicious activities, so implementing countermeasures around the abuse of those privileged accounts is equally as important as these other controls. So privileged access management has become as important a defense measure as anything that you're looking at on the kill chain. So the goals of privileged access management, one is to enable compliance, of course. Auditors have woken up to the fact that privileged accounts do get abused, and you might have an audit finding that says, hey, you need to do better about controlling these privileged accounts. You need to ensure that you have these under control, and you get an audit finding for that. When that comes up, it becomes a business problem, and oftentimes you could remediate that finding by simply applying a basic control. In that case, you would become compliant. I think it goes without saying today, but maybe it needs to be said anyway, that compliance is not the same thing as security. The fact that you turned up an audit finding and you remediate it with a simple control, such as maybe just only applying a credential vault, that may get you over the hump of removing the checkbox from your quarterly report, but you could still have a lot of risk. So being compliant is not the same thing as security, and the goal should be to be able to enable you to stop targeted attacks and really mitigate the insider threat, in addition to getting the checkbox for compliance. Compliance really should be seen as an outcome of good security, not as a goal unto itself. And by reducing risk, you can be compliant, but don't think of it as just a checkbox that you need to get off your quarterly report. Instead, proactive defense against external and internal breaches, it should be the outcome that you're looking for. And at the same time, as I mentioned before, people still have to do their jobs. These privileged accounts are used by administrators to do very important things. The textbooks say that the goals of security are to optimize confidentiality, integrity, and availability. And if you stop people from doing their jobs, you're going to suffer availability problems. So you do have to allow administrators to do their jobs while still addressing these other concerns. Some of the capabilities that would be present in a good privileged access management solution include strong authentication of users, a credential management system. I mentioned a credential vault a little while ago. A credential vault basically allows you to take the passwords that people are presently sharing and store those in an encrypted database with a service that allows authorized users, once they're authenticated, to take custody of those credentials to use them where they have a legitimate need. After they've used that credential, such as a password, that password could be reset so that if they did discover it or use the password and know what it was while they had it, they wouldn't be able to reuse that later. So a credential vault actually provides a control measure that says only authorized people can have access to privileged credentials, and that those credentials are being rotated. Another control, least privilege role-based access control. What systems can you access and using privileged accounts, and which ones can you not? You shouldn't have the opportunity to access things that you're not authorized for. Command filtering is a capability that it says, okay, so you can get to this server, but what can you do once you get there? What commands can you run? Perhaps there's a white list of commands that you should be able to execute and do nothing else. Or a blacklist that says, well, you can do pretty much anything you need to on this system, but you can't do this, that, or the other. Command filtering helps enforce that. Session monitoring, recording, user attribution, this goes to the heart of the accountability thing. If you're using shared accounts and two people or many people know the password or the credential for that shared account, which one of them did it? The credential management can give you a log of who took the password for a particular shared account. But once they've used it, how do you know what they did with it? And suppose two people were using that same credential on the same system at the same time. How do you know which one did what? Session monitoring is going to give you that information. And then finally, app-to-app security, app-to-app credential management, or applicative use of privileged credentials. It's not only people that use passwords, but some of your applications do as well. There's sort of a ticking time bomb that goes on there when these are neglected. So these are some of the control measures that privileged access management needs to address. Real quick, let's look through the kill chain then. You have your network perimeter and you have threat actors, bad guys on the outside. You also have possibly trusted insiders who are looking to maybe land and expand and maybe do something malicious. More often than not, the insider might be doing something accidental. But in the case of a malicious insider, you do have that threat to consider as well. So the first thing is to gain the access that they need, perhaps expand that beyond something that's legitimate for them to have, and then escalate privileges. Why would you do that? Well, if I'm with somebody who is on the outside and I want to be somebody on the inside, it really helps me a lot to be somebody on the inside with a high level of privilege, because I can bypass controls, I can land backdoors for myself, I can expand later, I can steal data. So the higher the privilege, the better chance I have of damaging or making the goal on the kill chain of taking you out. So once they've elevated the privilege, they'll now have some authority to do lateral movement, reconnaissance, basically expand their access even more and repeat until such time as they have enough authority to exfiltrate the data, cause an outage, or whatever their malicious intent was. They do this through stealing credentials. Either somebody's given their credentials and they had weak passwords, maybe not using two-factor authentication, perhaps even a zero-day vulnerability that doesn't even require credentials. Think about shell shock. It didn't really require a password for the attacker to take advantage of that. So stealing credentials or compromised credentials. SSH keys are another one they often neglected. Edward Snowden really abused SSH keys when he was performing his magic. What about lateral movement? Just because we let you on one system, does that mean we should let you on every system? Can you go outbound from this system to others that you're not authorized for? And what about when you get there? What commands should you be able to run? What things should you be able to do that administrators have? And then a lack of monitoring and analysis is a big problem. And that's oftentimes not due to the lack of will. It's oftentimes due to just simply the audit trails themselves really do not exist. Many systems do a very poor job of accounting for privileged access. So the control measures for this against these attacks would involve first, strong authentication. If you're using two-factor authentication, a good privileged access management solution should be able to include your two-factor authentication in its scheme. Ensure that privileged users are being strongly authenticated. And that's going to include whatever, multi-factor, PIV, CACA, PKI card, SAML, or some other form of authentication, as well as login restrictions. Where can you come from that would be legitimate? What about controlling access? Well, the zero trust model that we employ says that you have no access at all through our privileged access management system except what we explicitly allow. Once you're in there, you have all that access is based on your role, automated login, command filtering, as we described, leapfrog prevention to prevent you from going to systems that you're not authorized for after you've landed in one place, and then violation detection, notification, and so on. Continuous monitoring and logging, video session recording and termination, a DVR-like recording that you can play back later, as well as logging all activity and integrating that with your SIM. So Privileged Access Manager from CA is really we find a lot of advantages to this, and so do our customers. The first is it's delivered on an appliance-based form factor, purpose-built, very highly scalable. It includes the operating system, the database, the high availability, the load balancing. You stand up a cluster of our servers, and you don't need to add hardware on the front end to do that load balancing, HA, and DR. It's all built in. Also, all the features that you would expect to find in a Privileged Access Management solution are all delivered on this single form factor appliance. Unlike some competitive solutions, you don't have to stand up separate servers, separate infrastructure. It's all delivered on this very simple to deploy, purpose-built appliance. The operating system is covered, the database is covered, all the features are built in. Also, it addresses the entire hybrid enterprise, not just the traditional data center, but also your virtual software-defined data center, public cloud like AWS, as well as SaaS-based applications that may be using a standard such as SAML. So CA Privileged Access Manager is delivered in this appliance-based form factor with everything that you need in a very, very highly scalable model. One of our appliances could cover, record, or address at least 2,000 concurrent recorded video sessions at the same time. So that's concurrent recorded sessions, 2,000 per appliance. As you stand up a pair of appliances and they're load balancing, you're now at 4,000 concurrent recorded sessions. That's really light years ahead of what anything else in this space is able to deliver. Privileged Access Management is actually something that we've coupled with our longstanding leader in host-based access controller, which we're now branding as Privileged Access Manager Server Control. Provides mainframe strength security on Windows, Unix, and Linux systems, provide in-depth protection for those servers. There's probably an 80-20 rule that takes place here. So Privileged Access Manager is itself a bastion host model. That appliance or that cluster of appliances, all the user activity to the protected endpoints goes through this bastion host, or it's sort of like a proxy. And that network-based access control is probably all you need for about 80% of your systems. But for that other 20% where you might be concerned about a direct attack against the server, like because it has a shell shock vulnerability or some other reason that you would want to put in additional compensating controls, we deliver really the gold standard in Privileged Access Manager Server Control. Those privileged users have no special authority and can be defended against just like a regular user. What that means is you have a root user on this Linux system, we can still prevent him from doing things that he shouldn't be doing. So what I'm going to do now is pass it over to Chris Tippett. And Kristen, I think that you can make him the presenter.
Yep, I just passed it to Chris, so feel free to take the controls and share your screen now for the demo.
Okay, very good. All right, can you see my page?
It looks like a blank screen to me. There we go.
Now?
Thank you.
There we go.
Better? Okay. All right. Hello, everyone. My name is Chris Tippett, and I'm going to spend the next 20 minutes or so walking through a live demonstration of CA PAM. And as Steve mentioned, we're going to probably cover a lot of ground here. You might want to lace up your running shoes. We're definitely going to move quickly, and we're going to take a look at the primary capabilities of the solution. As Steve mentioned, this is a very broad solution, lots of capabilities. We're going to look at the more commonly used capabilities in this first session, and we'll probably go a mile wide and just a few inches deep. That is to say, we'll look at more of the what, what is the solution capable of versus the how today. We'll get into more of the how in the subsequent sessions. So what I'm going to do is, in this demonstration, I'm going to utilize several accounts to help me with this demonstration as I move through it. And we'll look at a full-blown administrator, we'll look at a DBA and an auditor, so different roles within the environment. And I'll start off by logging in as a full-blown administrator of the solution. And the first thing that you'll see as you log in as an administrator of the solution is a dashboard of sorts. It gives us a snapshot of the overall health and what's going on the appliance environment. So it shows us recent events, number of devices and users that are being managed, and so forth. In production, of course, these could be very large numbers, thousands of privileged users, hundreds if not thousands of devices managed, and so on. My environment is small. I'm running off of my laptop today. If we look at the access page, this is where your general users of PAM will land. That is to say, your privileged users, your network administrators, DBAs, sysadmins, and so on, will land here at the access page when they authenticate to PAM. And then this gives them access to the various managed devices, the endpoints that we're managing, the various accounts that are being managed on those endpoints, which ones are being authorized for a given user that's logged into PAM. So as an example, if I look at this CM Linux device or endpoint, I have SSH as a means for accessing that device. And if I click on SSH, it shows me that I'm authorized for 2 particular accounts on that endpoint that I can use, Oracle Backup and Oracle Operator. If I select Oracle Backup, the system will automatically log me in. It did not show me the password, just logged me in, and I can now start performing my work as needed. Any commands that I enter will, in fact, be recorded. So any activity that goes on during the life of this session will be recorded. If I exit out of this session, the session is closed, and in fact, I can go over to sessions and session recording and see that my session was already created. So there are the commands that I entered and so forth. We'll come back and look at session recording in greater depth in a few moments, but I just wanted to show you how that cycle gets completed. I go to a device, I select an account, I get automatically logged in, and the session is recorded. In a similar way, we could look at a Windows target server, and I'll select RDP as the access method. And as you can see here, again, I'm presented with multiple accounts that I am authorized for. As Steve mentioned, this is a zero trust model. There has to be 1 or more policies that grant me access to these managed devices and associated accounts, or I'm not going to have access at all. So in this case, I have access to 3 accounts, and I just wanted to point out that 2 are Active Directory domain accounts, and the third one is a local account on the remote Windows server. So we have the flexibility to manage both Active Directory accounts and local accounts. If I select DBA admin, it will log me into this remote Windows server using an Active Directory credential, DBA admin. As you can see, I'm logged in with that account, and I have now full access to this machine. And you might notice that I also have the message at the top of the page indicating that my session is being recorded. So, of course, that's the best practice to inform your users that they are being recorded. Looking at another use case, if I wanted to extend this capability to web-based applications, I could select Oracle ESXi in this case, and it will automatically log me into the Oracle utility so that I can, if I'm a DBA, perform the various tasks that I need to in order to maintain my databases. So, again, logs me in automatically, does not show me the password. You notice, again, I get the message that the session is, in fact, being recorded. And similar to our RDP example where I had logged into a Windows desktop, we can extend that to where we're essentially bringing another security control by allowing automatic login to published applications. And the idea behind this is that there are times we do not want to allow RDP to a desktop and grant an individual full access to that desktop, because while they might be there for a specific purpose, they could always launch the control panel, they could shut down antivirus, they could go into regedit and muck around, they could do many different things that we may not want them to do. So we can restrict them, in this case, to SQL Management Studio, and they can log into that particular application, and they can manipulate their database infrastructure as necessary, but then when they're finished, when they attempt to exit out of the application, they cannot get to a desktop. The entire session is collapsed and they're out. So again, the idea is to restrict them to one application. Another capability we have, and of course the best practice is to auto-log your users into a privileged account that they need access to on a given endpoint. But there are times they might need to view the password, and so we can authorize certain individuals to request the ability to view a password. And in this case, I selected an option where they have to select a reason or provide a justification why they need to view it. And in this case, I'll just put testing for my justification, but it will then show me the current credentials, right? So I see the user ID and password. You might notice the password has a prefix of CMT. That happens to be my initials. And when I set up my password composition policy, I wanted my initials as the prefix and then a bunch of other characters behind it. And I'll show you how that was put together. But an interesting and important aspect of what goes on under the covers is when I viewed that password, a job was automatically scheduled, and essentially we have a policy or multiple policies that say when our accounts get utilized, we want to schedule a password change job to run. So in my case, I have a policy set up that says when any of these credentials get utilized, whether they're viewed or whether they're just used for auto login, we're going to rotate those passwords. So you're seeing here a couple of jobs that are getting ready to run. In fact, it's 12:28 now. They're scheduled to run at 12:28 and 12:29 respectively. The latter one, 12:29, is the password change for that password that I just viewed, Oracle Backup. So the long and short of it then is we have a couple of components, and I mentioned I would just very lightly touch on the administrative aspects of our solution. We're really looking at just functionality. But I did want to point out the password composition rules. When we create an account, we specify which composition rule, password composition rule applies to it. And here we specify characteristics of the password. When it gets created, it should have uppercase, lowercase characters, numerics, non-repeating characters, minimum and maximum lengths, and so on. And once I create the policy, I can test it, and it will show me an example of a password that would be randomly generated. Okay, so that's the first aspect, the composition policy. And then the second aspect is a password view policy, or I refer to more as a password use policy. The idea here, and by the way, I named this default also because both the composition policy and this password view policy are reusable. I can use them for and I use them for most of my accounts. But it's very simple. It simply says that if someone views this password or if they use this credential to automatically connect to an endpoint, we're going to rotate the password after 2 minutes. And this is what caused those password change jobs to be scheduled to run. So really, that's in a nutshell. I just wanted to show you the mechanics of that because obviously for a solution of this type, that is core capability. We want to be able to ensure that passwords are being changed. Not only passwords, but other credentials, including SSH keys, are being rotated on a timely basis. So switching gears, I'm going to log out of the super account. I'm going to log in as another user, in this case Jeff Andrews, in my demo scenarios, a DBA, and he's going to log in using Active Directory credentials. We could use other, as Steve mentioned, multi-factor authentication. We can use CA's multi-factor authentication, of course, but RSA, PIV cards, CAC cards, any number of methods can be used. So I'll log in as Jeff, and you'll notice that Jeff has a subset of the number of endpoints that I had access to as super. There's nothing special about super. Super could have no access at all or just access to a few machines, but in any case, Jeff has access to 3. And when he selects SSH and connects to the CM Linux endpoint using the Oracle Backup account, the one difference between his access and super's access is I attached a blacklist command filter file to the policy controlling Jeff's access. So if Jeff were to try to perform certain commands, such as editing the ESXi host file, oops, it would help to spell it correctly. The ESXi host file, you notice when he attempted the edit on ESXi host, he received a violation message, and it basically indicates that a violation has occurred, and continued violations would result in an action being taken. Now, I could just suspend his session after X number of violations, but I could also take it as far as suspending his account within PAM, and then he would have to go to an administrator and explain his actions before getting reauthorized. But entering a few more commands, such as password or the user add command, would cause me to reach that threshold, and now my session is terminated. And a similar type of control that Steve had already mentioned during his presentation was socket filtering. This is a very powerful capability. You know, we often use network segmentation to control who can go where within our network once we allow them into our network. But when we think about use cases such as we have a development environment, and we might have dozens of servers involved in our development, being used in our development department. And even though we're using network segmentation for determining who can get to those servers within development, we might have offshore developers that we've contracted with, and they need access to some of those servers, but we want to control them so that they don't get access to all of them. We're going to restrict them to maybe 2 or 3 servers. We have the ability to do that. We have socket filtering. So what we can do, if I allow this individual to connect to this particular PIM SQL Server Windows endpoint, if they try going outbound then to some other server, in this case using PuTTY, they will be denied. So what happens is a socket filter kicks in. Because I had these outbound servers in a list that were not allowed, denied for this user, then they are blocked. And if I tried a similar command using RDP and tried going outbound to a Windows server, the same result would occur. I am blocked. So anyone that breaches your network, an outsider, a threat actor who breaches your network, some of the things they're going to want to do, of course, is to perform a discovery in your network. If they breached your network with a named account, something other than a privileged account, they're going to be very limited on what they can do, and they probably can't access your critical data, your financials, your intellectual property, and so on. But if they can escalate their privileges, that's what's going to get them to where they want to be. And so they'll inventory, they'll perform discoveries on your network. So if we have controls like this, even if they get in with a named account, we can restrict where they can go. And maybe they can't get to those application servers that are using, where our applications are hosted, that might be, in fact, using credential pairs stored in config files and so forth that would be vulnerable. So, you know, again, to Steve's point about utilizing a layered approach or, you know, defense in depth, that's what we're striving for here, and that's why we bring these different levels of controls, socket filters, whitelist, blacklist. So it's not only managing who can access privileged accounts, but what they can do with those accounts. Okay, so I'm going to log off of this account. And so at this point, what I'm going to do is go back to our super account, and I want to spend a little bit more time talking about auditing and session recording, because they are both done very extensively within this solution. If we go to our session logs, we can see log records for every event that has occurred within this system. And in fact, just the activity that I just performed by going into our log records and viewing them caused another log record to be created. And it essentially says that super is now viewing log records. So there really isn't a task that you can perform within our solution that isn't going to generate a record. And I can see everything that just transpired, all of the interactions that super had made, all of the interactions by Jeff Andrews. I see blacklist violations, and so on. So these are detailed records that tell me who the actor was on which system, whether they have violations, and so on. And then session recordings, of course, take that to another level. So looking at the session recording for the session that Jeff had just opened where he had RDP'd into an endpoint and then tried going outbound using SSH and RDP, this is that particular session in recorded form. And you notice I can play it back, I can speed it up, slow it down, just as I would with a DVR, and I can go directly to interesting points during the recording, such as these violations. And it'll take me right to where Jeff tried to go outbound using PuTTY and caused a socket violation. The other interesting thing about these session recordings, so we're pretty efficient on how we perform the recordings and how they're stored. So they are stored compacted. We take a hash value of the particular session, and you notice on the left-hand side here, we see that the hash is valid, it has not been tampered with, and it shows the size of the recording. It's 259 kilobytes. And of course, if we look at recordings for command line interfaces such as SSH sessions, they're much smaller. In fact, everything that we had performed, those 3 violations, the commands we entered, the password command, editing Etsy hosts, and so on, all fit on one page. And subsequently, this is only a slightly over 1.5 kilobytes, this recording. Okay, switching gears again, just to talk a little bit more about the administrative highlights of the solution. And we have an entire session scheduled amongst the next 5 sessions that we have over the course of the summer that would really be focused on the simplicity of the solution, how easy it is to administer, to maintain, and so forth. But just to show a little bit of that, if we look at the delegation model, we have about 18 roles out of the box that we provide. I'm logged in as a global administrator, but we have password administrators, policy managers, auditors, and so on. And then you can create a new policy from any of these and just set at a fine level the entitlements that you wish this new role to have, and that's all they'll be able to do. For instance, I created one for command and socket filter management, and that's all that individual can do within the solution. To show an example of that, I have another browser open where I have a user logged in, Sally Brown, who is an auditor. She's designated an auditor in our solution. Notice she does not have any devices or accounts that she can access within CA-PAM. Because again, zero trust model, there's no policy that specifically allows Sally to have access to an endpoint, so she doesn't. All she can do as an auditor is go in and view logs and view session recordings. Okay, so back to our super user. Another couple of points to make about administration is, when you think about the building blocks for how we put things together to allow the accesses that you had just witnessed, it's really quite simple. We have accounts, and then we have users. These are our privileged users. And then we have devices. And essentially, a policy uses those building blocks to say which users should we allow access to which devices, and then which passwords, which accounts rather, on those particular devices. So if I look at a quick policy here, we have one for Oracle DBAs for the endpoint CM Linux. Now, in production, it's typically going to be a device group, not a single device, right? It could be all of our finance Linux boxes, as an example. But in this case, it's a single device, and then anybody in the Active Directory group Oracle DBAs can have access to it. And we name the 2 accounts, Oracle Backup and Oracle Operator, that are authorized by this policy, whether we want a command filter to be in effect, and I have one named here. And then finally, do we want session recording or not? And I have that turned on. Very straightforward. That's what a policy looks like. They're easy to create. And then switching gears, I'm going to show, I have 2 more quick use cases to show you. And for the first, I'm going to log in as another user, Anita Hirsch. This is a full-blown systems administrator, not a PAM administrator, but a systems administrator. And therefore, she has access to systems-related, infrastructure-related accounts such as root on Linux and ESXi and so forth. For instance, if she needs access to the root account on ESXi, we have that configured so that she has to request access. This is referred to as a dual authorization policy. And she has to re-authenticate. That's optional. And then specify the from and to date and time when she wants to utilize this credential. And then we get a message that says that this is a dual authorization policy and that it would require authorization before she's granted access to this account. And she can now see that her request is pending. And then what happens is an email will get generated. And in my case, I have super designated as the authorization, the person to authorize the request. And so if I go to manage passwords, I can view that request, and I can go ahead and simply approve or deny her access. Now, again, an email would have been...
Hey, Chris?
Yes?
Just a quick time check. It's 12:42. I'd like to leave at least 15 minutes for Q&A and respect everyone's time. We can go a little over with Q&A if folks want to join. I just don't want to make sure we run too close to the end if anyone needs to jump off for a call at the top of the hour.
Very good. Okay. So I think I'm right on schedule. The last use case I want to show you then is A to A, or application to application. And granted, we have a full session on this, so we're not going to spend a lot of time on it, but it's an important aspect. When you think about this kind of a solution, it's not, as Steve alluded to, it's not only the interactive use of these privileged accounts that is important to manage. You might make the argument that you have greater risk with the application-to-application credential management because, again, if you think about having J2EE applications or other types of applications, let's say it's a finance app and it requires, when that application comes up, it has to access a back-end database, a SQL or Oracle database, for instance, where the financial data lives. So it needs to retrieve and to write data to that database. It very well is storing the credential to get to that database in a flat file, in clear text. And so anyone who breaches your network, when they perform that discovery and poke around on their network, they're going to be looking for those flat files. They're going to find out where your applications live. They'll look for a WebSphere server or a JBoss server living somewhere, and they'll poke around in your directories until they find those credentials. Very vulnerable. So what we want to do is instead have the application reach out to PAM to make a call to PAM and securely retrieve the appropriate credentials at runtime and not storing them anywhere in flat files. So if I launch this VB sample application, it's going to prompt me for an alias. So we're using aliases just as another security measure. So that if anyone looked at this application, they would not see the name of the account that's being used, much less the password. All they're going to see is an alias. And I'll go ahead and enter A2A Fin1 is the name of my alias. And if I enter get credential, and again, this is just a sample app to show you the mechanics of what's going on, but in reality, it came back and showed me the user ID and password that's in effect, but in production, the way this application would have worked, if this is your financial app, it would have retrieved, by way of this alias, this particular application credential, and it would have authenticated successfully to the back-end database, and the application would be up and running without the risk of having plain text passwords, credentials stored in flat files. Okay, and with that, I am going to turn it back over to Steve. That concludes the demonstration.
Great, thank you, everyone. Steve, did you have anything else to add before we open it up for live Q&A?
No, I don't have anything to add. Thank you, Chris. That was a good demo, given the time constraint that we put you under. So some of the details that would be the next level down of the topics that Chris was demonstrating today, like the simplicity of configuring the product, the features beyond the credential vault, the details around A to A, as well as our host-based controls and AWS integration, all are important capabilities that were kind of outside the scope of the high-level overview that you received today. but that's the reason why we broke it into different segments, and we'll be offering this over six different sessions on Friday at lunch. So thank you, Chris, for that. And I don't have anything to add, Kristen, so if there are questions, I think this would be a good point to take those.
Yeah, so our first question comes from Jesus. He asked, hi, do you have any issue when deploy the OVA of PAM 2.6 in ESXi 6B, like the studio password cannot be changed?
Yeah, I see the question. So the question is, so the appliance-based form factor, the appliance that we deliver for CA PAM can be deployed as a physical appliance or as a VMware appliance, and that includes as an OVA image that can be deployed on ESX. And there shouldn't be any issues with controlling access to the password. He's asking about a sudo password, but I think it may be the ESXi password. We do those via basically SSH connections to the hypervisor. So if that's what the question is, there shouldn't be any problem with doing that. All the capabilities that you have within CA PAM are the same, regardless of whether or not the appliance is deployed as a physical or VMware or as an AWS AMI. You would still be able to have equivalent capabilities to control access to those privileged accounts.
Okay, great, thank you. And there's another question that just came in, but I just wanted to let everyone know that I opened up a poll. So if you click on the polling box, please answer the question and just rate today's webcast so we know and get some feedback on the value of this webcast. I also posted a link in the chat window to a blog post with links to the rest of the events in this series, so go check that out and feel free to RSVP and add those events to your calendar. The next question from Guillermo, he asked, what applications are supported under A2A?
So the A2A applications are primarily to allow you to remove credentials from those apps that you have either the source code for or scripts that you can remove that maybe you have a hard-coded credential in. You can remove those scripts, you can remove those credentials from your program or from your script and then insert the alias, which you've configured through PAM, in your application instead. That would accomplish a couple things. One is to remove the credential, the password itself, from being readable by anybody who knows how to look in that script or in that configuration file of the application. It also removes from the developer the need to even know what credential is being accessed, because the alias itself is mapped to a privileged account. The developer wouldn't even know which privileged account that is. So there are a broad variety of different programming languages that we support, but the application itself really doesn't matter as long as you're using it in one of the supported programming languages we provide. Again, that support is very broad. I see another question about how do you prevent assets from being accessed by compromised domain IDs. So this question is that if someone is going through PAM, this is actually a multi-part question, I think. One is if the account has been compromised and that domain ID is being used as a credential for PAM, that would be a good case to be using two-factor authentication. In fact, as you concentrate privileged access into a PAM-like solution, and now through a single credential you're controlling access to perhaps, or granting somebody perhaps access to multiple privileged credentials, you can see that the case for strong authentication rather than password only is enhanced. So for that reason, CA PAM supports virtually any form of strong authentication. We don't tie you to one in particular. It could be a combination of LDAP plus Radius, it could be RSA, could be CA's advanced authentication. We do encourage the use of two-factor authentication so that you aren't using a single factor, such as a password that might be breached, and thereby you would defeat somebody who had perhaps compromised the domain account. and I think that actually is the best answer. For privileged access management in particular, two-factor authentication is strongly encouraged, and CA-PAM is completely flexible to support any form of authentication that you want to use.
The next question is from Chris Hartman. As a person who has been providing privileged access management solutions, he just said that he wanted to applaud us for what we've achieved with PAM. Okay, thank you, Chris. Another question from Guillermo. How many admins can connect concurrently through PAM, and how practical is it to have all admins going through PAM?
Well, this is one of the areas where we really differentiate ourselves, is through, as our appliance is been purposely built specifically as a PAM appliance, all the scalability has been really thought out, very well designed, and kind of artfully implemented. One of the things, there's a couple of things that happen through PAM. One is the credential vault itself, but the second is a very strong secondary control, and that's accountability. That accountability is achieved in a number of ways, one of which is through the video. As I mentioned earlier, there are certain use cases where if you want to know who did something, you have to have the video to get to the bottom of that. And the scalability is really a concern when it comes to concurrent users where you're recording the sessions. You can see that there is additional overhead put on the system when you're making a video of a session, not just granting somebody access. So when we're recording videos, or when any PAM solution is making a video of a privileged session, you'd like to know, hey, I'm going to have a lot of people doing this at the same time. What's the scalability limit? We are head and shoulders above the competition here. With just a nominally regularly sized appliance will comfortably support 2,000 concurrent recorded sessions. So 2,000 sessions open at the same time with just an average size appliance that we supply would be more than adequate. You could actually overachieve that number. Of course, for high availability, we always recommend that a pair of appliances be implemented, and when they're doing, they automatically are going to do load balancing so that it's an active configuration. Therefore, you effectively double the number of concurrent sessions. So say 4,000 to 5,000 concurrent recorded sessions through a pair of our appliances. We find in most normal data centers that's more than adequate, but it scales linearly. If you find that, well, in our shop we need to scale to 6,000 concurrent recorded sessions, you can accomplish that by simply adding a third appliance to the cluster. That's compared against other solutions that rely on using perhaps a Windows server, dedicated hardware for that, and they may tap out their scalability around 100, perhaps even as high as 400 if generous concurrent recorded sessions. So we've got an order of magnitude improvement over the competition with regard to our scalability. Thank you for that question.
Thanks so much. I don't see any other questions in chat or Q&A. If anyone would like, you can unmute your line by pressing #6 or *6, and you can ask a question over the phone. If you're dialed in through the audio broadcast, you can click the phone icon with a question mark to raise your hand. I see Chris Hartman has raised his hand, so let me unmute his line. Chris, are you there? Chris, are you there? I'm hitting allow, but it doesn't look like it's connecting.
I see that there's a follow-up question on the video. I see Chris says his speaker's not working. With regard to the video, the question has come up about, well, if we're recording everything, isn't that going to take a lot of storage? In fact, it does not. The video recording that we supply with PAM has actually been patented, and that patent involves a clever way of reducing the size of the video so that the amount of storage you need is very negligible. Essentially, as user, there's a clock associated with each video, and you can see as you're playing a graphical video that time is passing. but that video, as time passes, may not be getting any bigger. The fact is that only changes in user actions make the video get any larger. And those videos, so if you're sitting idly, the clock may be running, and you could see that running across the screen as the session is continuing, but the size of the video is not growing, the file itself. And the way those files are stored has been optimized, and again, it's a patented technology. The point is that we can scale to a massive enterprise and have a very small storage requirement.
Were there any other questions? You can unmute your line by pressing #6 or *6.
And by the way, regarding that sizing, we do have a spreadsheet. So when it comes time to look at your enterprise and we need to know how many users, how many sessions, we have a simple formula for calculating that storage. So it's something we encounter all the time.
All right,
This
if there are no any other, oh, go ahead.
This is Chris Hartman. Can you hear me now?
Yeah, we can hear you.
Okay, yeah. For some reason, I had to actually do #6 twice to get into your call, so from a remote line. So something's probably going on with your internal, speaker routine. But I will actually, let me close that off so you aren't hearing an echo. All right.
Yeah, if you just mute your computer, we won't hear the echo.
Yeah. Oh, that's what I'm doing. So anyway, no, I wanted, and this may have been, I had to take a call during the presentation, unfortunately, but I just wanted to ask you, from what I'm seeing, this is available as not only a hardened hardware appliance, but you have it as a virtual appliance as well. Is that correct?
That's correct. It can be as a physical form factor, VMware, or also as an AWS AMI. The features are the same regardless of the footprint.
No, I love the fact that you have the 3 options, and I also love the fact you guys are dealing with the very much neglected but very, very powerful SSH keys that are becoming the hackers' preferred way of getting into things. But just curious, you may have covered this, but as far as high availability, many people are trying to do their high availability in a virtual stance. So I was just curious, you can use your primary appliance within the network, but then you could go ahead and have your virtual appliance match up to it as the high availability. Is that correct?
Yes. In fact, there's a couple of different options there. First of all, the physical appliance could be paired with a virtual appliance, and that could help you achieve additional scalability. But remember, because it's active, you already have built-in high availability. And
right.
so the physical and virtual appliances can be joined into the same cluster, and if one goes down or if you have concerns about that, you can simply add another virtual appliance to improve the availability.
Perfect. And as you're referring to active, that's my old terminology for hot failover. Is that correct?
That's correct.
Okay. This is going to be fun to sell, my friends. That's all I can say. So that's the end of Chris Hartman's comments. Thank you.
Thanks, Chris.
Thanks, Chris. I got another question from Tim. How does PAM handle machines and DMZs?
Well, there's different configurations that you may want to consider as to where you put the CA PAM appliance. So the network routing really depends on what you want to do, whether you can get there from the PAM appliance. The appliance itself serves as a bastion host, and so end users are connecting to that, and it's really up to you how you wanted to handle the tunneling of traffic from the appliance or the cluster of appliances to the endpoints that are being managed. From there, it's typically whatever protocol the endpoint is expecting, like SSH or RDP. There wouldn't necessarily need to be in fact, that port would not need to be open between the user's desktop and the appliance. So different configuration options are available. There's only one port required between the user's point of entry to the appliance, and then You can route from the appliance to the managed endpoints however you need to, as long as you accommodate the protocol that the endpoint's expecting to be connected with.
Great, thanks. We have another question from Guillermo. Are there any limitations at all when you use a physical appliance versus a virtual one, whether it be when managed more than one appliance, clustering, et cetera?
No, it really comes down to a personal preference. Some customers simply want something that can slide into a rack and will go with a physical appliance because it's their preferred buying option or their preferred deployment option. Others like the virtual appliance because you can configure how much memory you put at, for example, and you don't have to handle a physical appliance. So anyway, it really is buyer's choice. There's very little difference in terms of capability. I will say that the hardware appliance does offer if you add a HSM card to it, it does give you a security feature that you can't get, which is hardware-based encryption of the appliance itself. So obviously, if that's a concern to you, sometimes people will go with the physical appliance because the hardware-based encryption is important to them. Obviously, hardware-based encryption is only available on hardware, so that might be another reason to go with a physical appliance.
Another question from Chris. How would PAM support migrations from other vaulting solutions such as CyberArk when swapping solutions?
Yeah, so the way the data gets into CA PAM is there's a number of ways you can get there, but the easiest way is just get it into a CSV. So other PAM solutions have information that's stored in relational databases or other stores, and if you can get that out to a CSV file, then we can migrate that over to a format that can be absorbed by CA PAM. It's a pretty straightforward process to migrate. We do accept CSV input into CA PAM, for example, so you get bulk import that way.
Okay, and another question, does the hardware include storage?
The storage for the logs is managed by you. So the logs are maintained in the appliance, and you can trim them on a scheduled basis, route them to syslog, and so on. The videos are stored in a mount point, either a CIFS or AWS or an NFS mount point, and that storage is managed outside the appliance. The reason for that is because appliances do come with fixed size, and because different organizations have different requirements for how many videos they keep online, we keep the video storage separate from the appliance. So that would be provided by, the videos would be stored in storage that you supply.
Okay, thank you. Any other questions? Last call. All right. I don't see any other questions at this time, so let's go ahead and wrap this up. Thank you so much, Steve and Chris, for presenting today. I'm looking forward to the rest of the webcasts in this series. I hope everyone enjoyed their lunch today. If you were snacking on something during the presentation today, I wasn't, so my belly's growling, so I'm going to go grab some lunch. But thank you again for joining. Thanks, guys. I'll post the recording and the slides from today's webcast to the CA security community, which you can find by going to ca.com/talksecurity. And I'll also follow up via email with everyone who attended today's webcast with links to those documents. And Chris and Steve, if there's anything else in additional that you'd like me to share via email with anyone from today's webcast, just go ahead and email that to me today, and I'll send that follow-up email out later today. So thank you, everyone. Have a great weekend, and we'll see you again on the next webcast. It's not next week because we have a holiday here in the U.S., but it will be the following week on July 8th. All right. See you then, everyone. Thank you.
Thank you.
Bye.